What's up, Clue Connors? We're 1 month in. Could really use a little bit of sunscreen right about now, but we're doing all right. Running low on water. I think things are going to be just fine out here. Let's open up the envelope and see what we have in store for us today. So now I'm here opening up envelope number 2. So let's see what this one looks like. Build a contraption that will purify salt water so that it is safe to drink. Use the Arduino board from your carry-on to test the amount of salt in the water. Well, I think we can figure this out. Let's go for it. Now, in order to measure the resistance of water, I have a couple tools here. An Arduino board, a breadboard, an LCD screen, and a bunch of cable wires. So, let's get this started. Now, I start with hooking up the LCD screen. Perfect, now my LCD screen is gonna be ready to go. Now I need to set up my breadboard to read the resistance. I hook up my resistor onto my breadboard and attach an alligator clip to what will be the negative side of the resistor. This is then going to feed into the negative power source, or the cathode, of my battery. Then on the same side as the negative, I'm going to plug in a wire and connect this to analog pin 0. Now, in order to set up my battery, I have a Tupperware container here, and on top I have a copper screw as well as a galvanized zinc-coated screw. The copper screw is going to act as my negative, and the zinc screw is going to act as my positive. So I'm going to hook up the negative alligator clip to my copper screw. Then I take my positive side and I'm going to hook it up to the other side of my resistor on the breadboard. Now let's give this some power supply and see how it looks. Now that we have our LCD screen running, we're able to read on the top our voltage. We can see our max resistance. We can see the unknown resistance, which is going to be the resistance within the water. And lastly, a little note that's going to say whether the water is safe to drink or whether it's not. A big question that we're asking ourselves. Now, because we're dealing with an alternating current, we have to read where the maximum resistance is in order to see where the peaks in our current are going to be. So we have this function that's going to read anytime we reach a certain threshold, meaning that the water is safe enough to drink given its high resistance. So let's test this out with some pure drinking water. Now, as we read the LCD screen, we get a little note that says the water is safe to drink. We reached a threshold of 32,000 ohms, which insinuates that there is not enough salt water in here to lower the resistance within the solution. With this in mind, looks like we're safe to drink. Now let's test this out with some salt water. Now that I have my salt water, I hook it up to my probes, and we're able to read that the ohmage is definitely changing, although it's given us a sign that we probably shouldn't drink this water. That was my little rendition of is this water safe to drink? I'm excited to see what you all come up with. See you on the community Slack channel and also at ClueCon. So see you guys later.